Welcome to our training on using managed Ethernet switches. We'll first give you an introduction. We'll go over unmanaged and managed Ethernet switches. Then we'll go over types of Ethernet switches, followed by why anyone would use managed switches. Then we'll show you how to configure managed switches, including using digital inputs and outputs, how to use email alarms, and we'll also go over different features including VLANs, QoS, redundancy, mirroring, and trunking. I'm Maria Limoni, Sales Manager here at ICPDASUSA, and have Robert Morale from our Technical Support Department with me. Later in the training, he will go over how to configure and use managed switches. ICPDAS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICPDAS USA was launched in 2001 to support North and South American markets. We have over 100 R&D engineers. We provide free technical support with the purchase of our products. We also provide free training classes and on-site services. On-site services, if it's very local, we may be able to come out and help you. Otherwise, we do provide on-site service for $1,000 per day plus traveling expenses. We can also provide customized training classes. For 2-day courses, it's $999 for the first engineer. If you want to have 2 engineers, then it's $499 for the second engineer. Just contact our sales department for more information. Unmanaged Ethernet switches allow Ethernet devices to communicate with each other. They allow for networking of Ethernet devices like computers, programmable controllers, and data acquisition modules together for data communication. Unmanaged switches allow for full bandwidth communication between a sender and a receiver. Ethernet switches like NS205 allow 2 computers in the network to communicate with each other at up to 100 megabits per second. Unmanaged Ethernet switches have no user configuration and are plug-and-play devices. Slower switches can be networked together with higher speed switches, but can only communicate as fast as their specifications allow. Managed Ethernet switches are configurable, allow Ethernet devices to communicate, and give you control over local area network traffic, how traffic travels over the LAN, and what devices have access to the data. They support user management and privilege levels, so some users can have full access while others are limited. Some users can have only read-only access, and others can upload software and change settings. Managed switches support DHCP, Dynamic Host Configuration Protocol, and can assign IP addresses to network devices. They support SNMP, Simple Network Management Protocol, and can collect and organize and exchange information between network devices. They support VLAN, virtual LANs, for safeguarding information, so they will only forward broadcasts to designated hosts in the same VLAN group instead of to every device on the network. They provide QoS, quality of service, so you can see the overall performance of the network. Port mirroring sends a copy of all network packets seen on one port to another port, where the packets can be analyzed. If you have any questions at any time, please type them into the chat box. The main difference between managed and unmanaged switches is managed switches offer configuration and network control capabilities, giving you control over your local area network traffic. Unmanaged switches only allow Ethernet devices to communicate with each other over the network. They are plug-and-play devices with a store and forward type architecture, so they just forward the data on to the destination device. A managed switch allows users to adjust each port on the switch with any setting you want. With a managed switch, you can monitor and configure your network in many different ways. NS205 is a very popular, compact, robust, and DIN-rail mountable 5-port industrial Ethernet switch. It has 5 Ethernet switching ports that support 10-100 base TX with a 10-100 megabits per second auto negotiation feature. Through its 5 ports, it can be used to connect 5 workstations, or 4 workstations as we saw earlier, and it can automatically switch the transmission speed, whether it's 10 megabits per second or 100 megabits per second for corresponding connections. The flow control mechanism is also negotiated. There are activity linked data rate LEDs for each port, which aid in troubleshooting. This is typical of most Ethernet switches. Port connectors are shielded RJ45, and it contains a soft start function with overload protection and high voltage protection. They operate in a wide range of operating temperatures from -40 degrees Fahrenheit to 167. NS208 PSE. It's an unmanaged Ethernet switch with 8 PoE power over Ethernet ports. The PoE ports are classified as PSE power sourcing equipment, which provide up to 15.4 watts of power per port and can be used to power compliant PD devices. Ethernet cabling eliminates the need for additional power wiring on your network. They're widely used with PoE web cameras, remote I/O modules, and in control and monitoring applications. Some Ethernet switches, like the unmanaged NSM216, have redundant power inputs, so 2 power supplies can be connected, and if one fails, a relay output gets triggered, so things like a light could go on for reliability, and this ensures reliable communication. The FSM510G is a managed switch with fiber and Ethernet communication. It can be managed through the RS-232 serial port via direct connection or through the Ethernet port using Telnet or a web server. It has an SNMP agent, so the network administrator can log on to switch monitoring, configuration, and control over each port in a friendly way. It also supports QoS, spanning tree, VLAN, port trunking, bandwidth control, port security, and SNMP. For example, if you have voice over IP systems on your network, they may take a lot of bandwidth, so you could dedicate ports just for those. That way the other ports on the network and the other users, they would have less priority. The MSM6226 is a managed Ethernet switch. It has 24 fast Ethernet ports and 2 gigabit fiber ports. It can also be managed over the serial port via direct connection or through the Ethernet port via Telnet or web page interface. It also has the SNMP agent and the same type features as the previous fiber switch. It also has a IGMP snooping capability with intelligent software for monitoring applications. Here you can see the 24 fast Ethernet ports and the 2 gigabit ports, also the LED indicators which indicate port status, run status, and power. There's also set and reset buttons that allow you to reset the system. This is very easy to use and saves a lot of time during configuration and troubleshooting. These are used in a lot of buildings and houses, and they're connected to outdoor lighting and surge protectors that protect Ethernet network access points from high voltage and lightning. That ensures the safety of the whole network communication system. The MSM6226 managed Ethernet switch takes in camera footage data from the outdoor IP camera. The MSM6226 allows for a specific port on the network to handle the traffic from the IP camera, which makes the whole home security system safer, more reliable, more customizable, and it's easier to detect communication problems. Camera traffic takes a lot of bandwidth, so with the managed switch you can dedicate one port to handle the load, not affecting the rest of the network. Ethernet switches are categorized into two main categories, modular switches and fixed configuration switches. Modular switches allow you to add expansion modules to the switches and offer great flexibility to address changing networks. Examples of expansion modules are application-specific, such as firewall, wireless, or network analysis. Broad type switches are fixed configuration, so the switches come with a fixed number of ports and are not typically expandable. So, when do we need to consider using a managed switch instead of a managed one? With a managed switch, you can choose the optimal operating parameters for your network ports instead of using auto-negotiated settings. A managed switch is a switch that supports SNMP. Within a managed switch, there are data locations that supply a wealth of knowledge about how the system's operating. For example, with SNMP, you can examine exactly how many messages and what message types are being received and sent from each port. You can also identify the number of drops or faulty packets in order to check the system for devices that may be causing communication problems. So these managed switches really help with finding the problem in network communication. There are many ways to configure managed switches. You can use a Bonjour software to discover devices like printers and computers in your network, and you can use that to troubleshoot communication problems. As we discussed earlier with the VLANs, you can also use that to see how traffic is controlled. In this diagram here, VLAN 1, the members in VLAN 1 cannot access VLAN 2, VLAN 3, and VLAN 4 members. All VLANs only have access to the ports assigned to them. So this is a good way to separate traffic and to protect devices from each other for security. You can configure the managed switch via its RS-232 port. To perform the configuration through the RS-232 console port, the switch's serial port must be directly connected to a DCE device, for example, a PC, through an RS-232 cable with the DB9 connector. You run a terminal emulator on your PC with the default setting of the switch's serial port. Then you can communicate with the switch. Some of the managed switches, like MSM508, have digital inputs and outputs on board that can be integrated with other I/O, programmable controllers, and PC systems. You can use the digital outputs to trigger audible alarms or warning lights based on conditions. MSM508 has 3 digital inputs and 3 digital outputs. When connecting to remote I/Os like the M7000 Modbus RTU-based I/Os and the ET7000 Modbus TCP-based I/O modules, their digital outputs can be triggered to send alarms or to turn on lights. We also have a WISE series of Modbus I/O that can send email alarms based on input conditions. There are a lot of scenarios where you might want to send email alarms over a network. When a service machine has an error, when a mail sorting machine is full, when an ATM runs out of cash, or when a vending machine is full of cash and coins, email messages help to alert proper personnel to service a machine so it can be used again. Managed switches can be configured to send email alarms to users in case of emergency, and it helps prevent further financial loss through a very easy-to-use user interface as well. Based on the physical layout of your network, there are different Ethernet network topologies that are implemented. A network with 2 devices and a cable between them is point-to-point. A network with more than 2 points is a bus network, which is a network where every node is directly connected to the main cable or backbone. A data signal travels in both directions to all machines on the bus cabling until it finds the intended recipient device. If a device's address doesn't match up to the intended destination address, the device just ignores the data. If the data matches the machine address, the data is accepted and processed. Bus topology is inexpensive, simple, and easy. However, it's difficult to troubleshoot, since if the main cable breaks, the entire network goes down. If one of the end devices aren't working properly, The rest of the network is not affected. Star topology consists of a central hub or switch device, which is connected to all the devices in the network. The hub or switch takes a signal from any node and passes it along to all the other nodes in the network. A hub does not perform any type of filtering or routing of the data. It is just a junction that joins all the different nodes together. An advantage of star topology is the simplicity of adding additional nodes. The primary disadvantage of the star topology is that the hub represents a single point of failure. It's often used in server or printer applications and is most widely used. It's the most widely used network topology. With ring topology, each node is connected to exactly two other nodes, forming a circular type of pathway for data to get across the network. If one of the links in the network is broken, the rest of the network is still connected for reliable data transfer. A fully connected mesh topology is where every node in the network has a connection to each of the other nodes in the network. Partial mesh topology is where nodes are partially connected to each other in a mesh format. Tree topology is one of the most commonly used and combines bus and star networks. An entire system can be affected by damage of the primary node. There are many features on managed switches, and they vary based on manufacturers and models, but they often include the spanning tree protocol, STP, the ability to implement quality of service, the support for VLANs, bandwidth rate limiting and port mirroring, and managed switches usually have a remotely accessible console via command line or web interface, which allow administrators to make changes or adjustments without having to be in the exact physical location. Port trunking supports static port trunking and port trunking with IEEE 802.3 AD LACP. The access control list capabilities allow for flexible dropping, rate limiting, mirroring, or the logging of traffic. Port mirroring is used on a network to send a copy of a network packets seen on one switch port to a network mirroring connection or another switch port. This is commonly used for network applications that require monitoring of network traffic, such as intrusion detection systems. Network engineers or administrators use port mirroring to analyze and debug data, diagnose errors on a network, and to troubleshoot. It helps administrators keep a close eye on network performance, and it alerts them when problems occur. It can be used to either mirror inbound or outbound traffic on a single switch or single port. While we transition over to Robert for configuring managed switches, I want to mention we provide free technical support, a wide variety of modular solutions that meet many different application requirements, low lead times, customized product and OEM capabilities. If you have any questions at any time, please enter them into the chat box and we'll be sure to answer them.
Thank you, Maria. Okay, today I'm going to go over configuration of a simple managed switch. This is our MSM 508. It's a 5-port managed switch with additional ports. Let's see, specifically it's got COM ports and I/O built in. Let's see, the steps for configuring the module. It's got a built-in web interface. This is the way I like to interface with the module. To do this, you simply open your web browser, type the IP address. In this case, it's the default IP address of 192.168.255.1 into your web browser. Internet Explorer, Google Chrome, Mozilla, Netscape, all are supported. Once you type the IP address in, it'll connect to the module. You'll be required to log in with the default password of admin for both the username and password. And then, let's see, then you go to the web configuration page. From the web console, you can configure the managed switch in many different configurations. You can choose which features you choose to use. The hardest part is determining which one works best for you. So from this screen, you can see there's different categories and different places to click for each feature. There's redundant settings, port configuration settings, relay alarms, email alarms, VLAN, QoS or quality of service, diagnostics, and authentication. Authentication will allow you to create administrators and users in which restricted access to the configuration where you can view the status of the switch, but you can't change the configuration. So by using authentication, you can restrict access and allow different either members or categories of users to restrict access and allow for configuration and viewing of status throughout the switch. IP filtering allows certain IP addresses to be able to access other data within the network. It allows IPs to be filtered so that you can restrict access, say for public IP address or for searching of the internet. Let's see, diagnostics. This is a diagnostic screen. So from this screen, you can see the status of the network. You can tell if something is connected to it, and you can even tell the cable length. If you're, say, debugging a device, you can tell if communication is good. Let's see, if you want to add a line, you can tell which connections are being used, even though there's a cable connected. And there's many other, ways to use this diagnostics for troubleshooting your network. The MSM508 can also be used as a Modbus Gateway. It's got an RS-232 port on COM1 and an RS-485 port on COM2. From this, you can treat the switch, which has an IP address, and port 502, and talk to the slave devices connected to the RS-485 or RS-232 device, and you can set a Modbus ID for the gateway in the Ethernet settings, and the COM port configuration for the slave devices would be configured in the COM port settings. You just simply configure this and it'll act like one of our TGW modules. So you can, if you have Modbus devices on the network, you can use this feature built into the MSM508. The next feature I want to go over is VLAN. Like Maria described, you can have multiple networks within one switch, and you could allow for the different networks and who can talk to who. Let's see, this is the configuration. There's two choices. You could use checkpoint mode, or I'm sorry, check mode or secure mode. The check mode allows for forward ingress frames that frames aren't interesting. Let's see, the English is a little bit bad, but let's see. Essentially, it allows for you to either secure access or restrict access. Let's see, the next feature, quality of service. This is one of the more commonly used features. Like Maria said, a webcam is a perfect use of, or perfect time to use this feature. Webcams use a lot of data, depending on if you want to maximize or minimize the effect of IP cameras on the rest of the network. You can use that, and there's two choices in the quality of service that we offer. One, wait fair queue scheming allows you to prioritize all frames, whereas you could do strict priority scheming where it only sends the highest priority first. So you have a hierarchy of connections. The next feature, there's built-in I/O into the managed switch, as Maria mentioned. From this, you can trigger alarms to show connectivity and if there's a loss in communication. You just check the check boxes and submit to set the configuration. Email alarms. Let's see, if a failure in the network occurs, you simply choose the feature and enable it, and you can tell whether communication loss or a link loss occurs in the system, and you can send an email alarm. This is part one of the configuration where you select what features you're looking out for, and then here is the configuration for the email alarm setting. You can choose the radio button to disable the alarm, resend, or you can set a search and frequency if the alarm condition stays. So you've set the mail server IP address, the sender as meaning is the person that's sending the email. You would probably put like a router or switch or something or network, and then you send the recipients in the boxes below, and you simply click on the submit, and you can also send a test email from this screen. Let's see, those are some of the services. We have other switches which have additional features like fiber optics. We have ring switches, and we have, let's see, more advanced features in our MSM 6226, but that just shows a few screens for how we configure our managed switches. If anyone has any questions, please type in the chat box.
If there's no questions, then you can contact us at any time, call us or email us. We'd be happy to help you. Thanks for attending and hope we can help you in the future with projects. Thank you so much. Happy holidays. Bye-bye.